Hello, it's Mr. Mulholland. Today I'm going to be showing you how to make the bolt that will fit the nut we made last time. So this is quite a big project, but I'm going to break it down into simple steps for you and you should be able to follow it to make a nut and a bolt. So we're going to open up a new part and we're going to check our dimensions. We're correct there and we're correct there. We're going to open a new sketch and we're going to choose the front plane. Now there's two ways you could do this. You could do this using the revolve tool, which is how I'm going to do it, but you could also do it by stacking circles on top of each other. I'm going to use the revolve tool because it uses less processes. If you're more comfortable by extruding the circles on top of each other, you do it that way. So just like always, we are going to do our little L shape. Now that we have that, we are going to sketch the profile of half of our nut. So we're going to draw the shaft first, and it had a diameter of 5mm, which will give us a radius of 2.5 because we're halving it. Or what we could simply do is we could type in 5 divided by 2, and that will give us our 2.5 radius. It was 16mm tall, and that's not going to change because it'll not change because this is not where we're halving it. We're halving it along the vertical axis, not the horizontal axis. And this is the vertical axis and this is the horizontal. So now we're going to draw the top, which would look something similar to that. And it had a diameter of 10. So just like before, I'm going to type in 10 divided by 2 to give us 5. And it had a height of 6. So now that we have our shape, what we're going to do is we're going to revolve, pause space, and we're going to choose our axis of revolution as the center line from the start, and our selected contours are going to be both of these shapes. So you see we have the beginning of what looks like a bolt. This is going to be a hex bolt. This means that you can use an Allen key with it to screw it and unscrew it. So what we need to do is we need to draw the little fitting point for our Allen key on the top face. So this is very simple. What we're going to do is we're going to open a new sketch on this top face of our bolt. And we're going to use the polygon tool again. And we're just going to draw a little hexagon. So a hexagon has 6 sides. So if you need to change this, the number of sides, you can change it, but it just happens to be correct. So when we've drawn our hexagon, what we need to do is we need to dimension it. Now the dimensions I took this morning shown that there was a distance of 5mm between the two flat faces. So if we type in 5, that should give us a distance of 5.77 between the corners, the two corners. So what we need to do now is we need to cut this shape. We're just going to use a simple extrude cut, and we're going to have a blind cut of 4mm. That's just from the measurements I took this morning. There might be different nuts and bolts out there that have different dimensions, but this is the one I took dimensions from. So there we go. We are nearly there. What we've got to do now, we've got to add our thread. Like I said the last time, it isn't actually that often that you use real threads in Solidworks, because it takes a lot of skill to make a thread in Solidworks, and 2, it's a bit pointless because in real life you very rarely use a machine to put a thread on. you would use a die and a tap. Unless you're 3D printing, or unless you have a fancy mill, CNC mill, or CNC lathe. Very few places have. So what I'm going to do is I'm going to open a new sketch on this face, on the bottom face that we just cut onto, below the top. So we're going to open our new sketch there. And what we're going to do is we are going to convert the entities, and we're going to choose the circle of the shaft. So that face, and we know it's correct because it all lines up. And what we're going to do now is we're going to use the helix and spiral tool to make that the outline of our thread, the outline path of our thread. And this is where it's very important to remember the pitch that we used for our nut, which was 1 millimeter. And your revolutions are 16 because this shaft has a length of 16 millimeters. And if it's 1 times 16, that'll give us the exact length of a shaft of the threading that we need. Because this is an additive process, if we extend beyond the length of the shaft, it'll give material beyond the shaft. This can create issues, so we only want it to have a depth of 16 mil. That's why it's important that it doesn't extend beyond the shaft. And we're going to choose clockwise. We're going to tick green tick. And what we need to do now is we need to create a new plane to draw our extrusion on. And what we're looking to draw our extrusion on is this point, or else this point. I'm going to draw it on the top point, purely because there's not as much in our way of our sketching, so it'll make it easier to see. If you're drawing it at the bottom, you have all this here to put up with, all the top of the nut, and the top of the bolt, sorry. So what we need to do is we need to go into our features, and we're going to select our new plane. And the first point we're going to pick is just the top point of our helix spiral. And our second reference point is we're going to choose one of the pre-existing planes. And I think it'll be the front plane, looking at the outline. And the front plane is going to be parallel, and the first point is going to be coincident. And just going to have a little look at the blue box before we click. And yeah, that looks exactly where I want it. And what I'm actually going to do now is I'm going to rename this plane to our thread. We're going to call this plane thread extrude. And there we go, we have our new plane. And this is very similar to the spring video. If you need help, you should go to the spring video. I go over these steps in more detail. Hopefully you've picked up some of my tips and tricks throughout these videos. So now that we have our path for our extrude, what we now need is we need our profile that we're looking to extrude, or if you prefer to think of it as your tool. Now we're looking to draw it on this point. And it's actually going to be easier to draw it from this side because it's going that direction. So the first thing we're going to do is we are going to open a new sketch on our thread extrude plane, and we're going to convert our entities. And the entity we're going to convert is we're going to convert this helix. And we're going to tick the green tick, and now we have a start point. So the last video when we were making the nut, we used a center square, but this time we're going to use a corner square, corner rectangle. and we're going to begin drawing it on this point. If we drew a center square, our thread would extend beyond our bolt. With the nut, this doesn't make a difference, because naturally in a nut, if you look at a nut, the thread could keep going. But with our bolt, there's a set distance that it can go to, and that set distance is between here and here. In this example, it's 16, but if that was a different shaft, it would be different set distances. Also, this is where it becomes important to remember your measurements from the last time. So I done 0.5 by 0.5 center square, but I cut it in half. So that will give us 0.25 by 0.25. So we're going to smart dimension this corner rectangle, which is on that point. See the point at the top of the convert entities? And we're going to make this 0.25. Do you remember that's because we cut our rectangle, our square, in half the last time? And even though we halved it in one direction, we want to cut it in both directions, because if it's too tight, you'll not be able to put it together. 0.25. Because if we use 0.5 by 0.5, it would actually be too big to fit in the nut. Next, we're going to use Sweep Ball Space to select our profile, which is the square we have drawn, and our path will be the helix. And our path is going to be that, the helix. Click the green tick, and that's us. So you can see that we have made our bolt that should fit our nut. Next time what I'm going to show you is how to make these two parts go together in an assembly, which is easier than what you might think.